Hello, this is O'Morgan Labs. We're going to do the tractor beam problem today. Find the acceleration vector of a tractor beam, a malfunctioning tractor beam. Spaceship makes the error, and instead of beaming up his passenger, the passenger just slowly falls to the ground. Takes him 8 seconds, and he falls 125 meters. The hard way, the way that I did it with another student, this kind of came from, I was helping somebody out, I was tutoring someone, and we did it the long way. But anyway, you can use the VF equation. Your VF equals V naught plus AT. You can combine that with VF squared equals V naught squared plus 2AD. You can do a simultaneous kind of equation operation in algebra. Plug 1 into 2, and you end up getting something like AT squared equals 2AD. Do algebra, and you come up with this here. This kind of looks like your distance equation, right? So they're all related. So the easy way is just use this distance equation here, the one with 1/2 AT squared. Start with that, because if you think about your problem, it gives you time, it gives you distance, and then acceleration, you can kind of find it with the other variables. So this is the one you should have used, not the other way around. That was hard. Another important point, everything is moving down. The person's falling real slow. So everything going down is positive. So I define down as positive so our units or our signs won't get messed up, okay? It's a good thing to do that. You just kind of think of your situation and how things are moving, and however things are moving, make that the positive, okay? So we do that. This should be Y. It falls plus the passenger, not it, him or her, 125 meters. The initial velocity is 0. We just kind of assume he's kind of was hovering there, and maybe it was like a glitch in the system and he started slowly falling. Y naught is 0 because we kind of start with no displacement, and T is 8. We plug everything in and we get 3.9 meters per second squared. Okay, that's supposed to be per second squared. There you go. We have our acceleration. That's our total acceleration now. Remember, in the back of our head, we have two vectors that are summing to get our answer. We have this acceleration vector from the tractor beam pushing it or pulling it up. I keep saying it. The person up. And then we have gravity going down. And then it equals everything is falling, so the arrow points down. Okay? You have to think about your situation, try to get your arrows right. But if you don't get your arrows right, you can flip them. I have that in another video. Go check out When to Flip Vectors video. Now, we plug everything in. It's minus A minus the 3.9 plus G. So G is plus 9.81 because down is positive. G is going down. So it's plus 9.81. So 9.81 minus 3.9 is 5.9. And if you see here, we get a positive number. Everything's good. We assume the correct direction of our tractor beam acceleration vector. Okay. All right. Hope you learned something. This is just basically using what I call the distance formula, not the point-to-point distance formula that you probably saw in Algebra 1, or the one-dimensional constant acceleration rectilinear motion equation. That's a lot. just the distance equation with 1/2 AT squared. Talk to you later. Enjoy and subscribe.